Greetings, everyone. We, the students of Thapar Institute of Engineering and Technology, have made our capstone project on the topic Flood Prediction and Destruction Calculation System for Urban Cities under the supervision of Dr. Vinay Kumar and Dr. Rahul Upadhyay. Starting off by introducing ourselves, Khushboo, Electronics and Computer Engineering,
Laxmi Saxena from Electronics and Computer Engineering.
Mehak Electronics and Computer Engineering.
Riya, Electronics and Computer Engineering.
Samarth, Electronics and Computer Engineering.
So, flood have been a significant natural disaster causing immense loss of life and property damage worldwide. The devastating impact of floods have highlighted the critical need for improved flood prediction and damage assessment system. Motivated by the desire to enhance disaster preparedness and response, our project aims to address these challenges through development of integrated system.
The objective is to use state-of-the-art algorithms and data analytic approaches to observe, forecast, and accurately quantify the potential devastation caused by floods. The approach aims to identify flood risk by taking into account many criteria like elevation, land use, area, population density, and rainfall. The primary objective is to provide communities, emergency management organizations, and policymakers with prompt and dependable information, allowing them to make well informed choices, take preventive actions, and allocate resources efficiently for disaster planning and response.
We have made a user-friendly website that provides convenient access to flood forecast and destruction calculation in metropolitan areas of Punjab and Haryana. The technology allows users to enter their state, city. It all provides flood forecast classified into low, medium, and high risk categories. By using elevation and rainfall data that is tailored to each unique location, combined with land utilization, population density, projected flood information, potential devastating caused by flood can be predicted.
As a first step, we shall collect the user's input regarding location and date for which they want to predict. We will forecast how much rainfall will be recorded. Then we will determine if there will be low, moderate, or high flood possibilities by combining the area's elevation and rainfall. This predicted flood category, combined with other metrics such as population, area, and land use, will help determine the possible destruction of that region.
due to unavailability of labeled datasets for this study, we chose to go for unsupervised learning and used k-means algorithm for clustering of flood values. We first calculated the optimal clusters that should be formed using the elbow method. It turned out to be 5 and the clusters were distributed as follows. Similar was done to find clusters of destruction. The optimal value of k from elbow method came out to be 3 and the clusters were distributed as follows.
The unsupervised learning process successfully assigned cluster labels to the dataset, transformed it into a labeled dataset for further analysis. Various supervised learning classification models were involved on this labeled dataset for prediction tasks. Models include logistic regression, decision trees, random forest, SVM, and KNN. The accuracy of each classification model was assessed using appropriate evaluation metrics.
Classification models demonstrated varying accuracies in predicting outcomes for new unseen data. Model accuracies ranged from 93% to 98% in flood prediction, while 54% to 97% in destruction prediction, highlighting the performance diversity across models.
In our website, first the user will select the state. Herein, we are giving currently only two options as we have the data set of only Haryana and Punjab. The user will select the state and then the city from the drop-down menu. Now, the user will select the month and the year for which he or she wants to predict. Here, user selects the month and the year and clicks on submit. Here, the elevation of that particular region is displayed in meters. Then, the rainfall prediction is displayed in and in a particular range. Now, based on combining these both metrics, now the flood is predicted. Herein, flood is predicted as low. Now, the land use of that region is also specified. The population and area is also given here. Now, combining all these metrics along with flood, now the destruction predicted is displayed. Herein, low destruction is predicted.
Overall, the outcome of the project are aimed at minimizing the destruction impact of floods, saving lives, reducing property damage, and building resilience in flood-prone regions. Thank you.